We're recording?
Yeah.
All right. Rocket City Podcast, how's it going today? We have a special guest here. My friend, Sean Heflin. How's it going, buddy?
That's me, man. What's going on, buddy? I'm doing well. How are you?
Good. So, Sean,
What's up, buddy?
today we're going to talk about some wild stuff, some controversial things.
Yeah.
But Sean, first off, let's get a little background. Where are you from, buddy?
I am from Houston, Texas, born and raised.
Tejas.
Yes, sir. Space City. Growing up all around it. Had a fun time.
Wait, they call it Space City?
Yeah, it's Space City out there.
Oh, so we call it Rocket City here
Yeah.
and Space City there.
Because
we
we build rockets there, and then you had the whole mission control out there. But
yeah, that makes sense. Anyway, keep going.
But yeah, honestly, something kind of cool that's kind of a small. This is how I kind of grew up with it. My dad actually worked on the ISS for a while. Yeah.
Whoa.
Yeah, he was part of the schematics team, which is cool.
Really?
Yeah, part of the scheduling team, which was really cool. But yeah, man, I'm from Houston. I was born and raised there. I've grown up a lot around, science and space and all kinds of different sorts of things. That's kind of what I'm studying now. Like, I'm going to school for astrophysics.
Okay.
And then my goal after I get my undergrad is to get space science in my graduate. So, like, my main objective for school is to try and determine the Earth's place in the universe. Does that make sense? Like, we have such a dimensional spot of where we are. It's so infinitesimally small that it's difficult to put into words how minute I don't want to say this, but our existence is. And that's why when, the way we live our lives, the way we do things is just kind of unique. But yeah, that's kind of what I study. That's why I do what I do, is I like to understand where we come from, where we're going, all this kind of different stuff. But yeah, that's a little bit about me.
That's amazing.
Thanks,
and
man.
that goal just really it trips me up because
Yeah,
that is a very important factor to really understand.
Yeah.
And how we interact with the world,
Mm-hmm.
and some of the topics you want to talk about today.
Yep.
And interacting with the world,
Yep.
which I think a lot of people don't understand, is that there's a lot of things that interact with us. Your
Yes.
cell phone, electromagnetic
A
frequencies, how your brain works.
Yep.
I mean, there's talk about the CIA being able to manipulate your brain through radio frequencies anyway. That's a little
Not
further
surprised.
down the road.
Yeah,
Yeah,
not
surprised.
surprised,
So
honestly.
it's very controversial. I mean, so why don't you start us off? Because I'd rather go down the rabbit hole from you.
Cool, man.
where
All right.
you built
so,
it.
Yeah.
Because I'm already going down the rabbit hole of the CIA
Nice, all right.
controlling our brain.
So I'm gonna probably start at the beginning. Typically, what I'm gonna be talking about a lot of today is frequency, harmonics, vibration, how we as humans interact with the outside world and all this kind of different stuff. But just to kind of get this started off, to make this easier, it's easier to know what we're talking about when we actually define what it is that we're talking about. So a lot of people hear the terms frequency, oscillations, harmonics, but not a bunch of people actually understand what they are. So I'm going to put it in terms that I understand, and if I understand it, because I'm dumb as a bag of rocks, then I know that everybody will understand it. So
I like that.
frequency is essentially the period, how often something occurs, whether it's when you're driving a car, your car, it has that 1 through 10 for your not your speedometer, but like for your engine itself, with the combustion engine, it has certain revolutions per minute. It goes from 1 up to 8 or 9,000 revolutions per minute. That's a frequency. That's just event per time. That's kind of the idea behind it, is just something that's happening in a specific time frame that will repeat, like kind of how hang on. So
Okay.
Yeah. So it's just simply the rate at which something occurs, like RPM, revolutions per minute, meters per second. It's velocity, like miles per hour. There's a bunch of different type of frequency, and then you also have sound frequency, which is measured in hertz, which again is a measure of time. It's 1 over the period of revolution, but
and a lot of times on graphs, that's like the wave.
yeah, like the sinusoidal wave.
Yeah.
That's kind of the frequency. The frequency has to do with, like, here, since I have the board, I might as well.
And he brought the board.
Yeah,
today
I brought the board.
Just because to throw back to Joe Barry's episode, he was like, "Wow, that's the episode that you need to really."
Yes, Joe Barry is a man, the myth, the legend. If you have not had a chance to check his episode out, look at his episode on Rock City Podcast. He is the greatest and genuinely a very smart individual. So just to kind of show you what we're going on here, like you have a graph here, right? So you have a long wavelength. So I'm going to have, it's going to be a multiple different type of I'm gonna have wavelength, which is measured in the Greek letter of lambda, and then I'm gonna have V, which is frequency up here at the top. So you have your wavelength.
Physics 101.
Right. So you have your wavelength, and the longer your wavelength itself, the bigger the frequency. Or no, smaller frequency. No. Smaller frequency. There you go. Okay. So as you increase your frequency, frequency and wavelength are inversely proportional. So as you increase frequency, you decrease wavelength. Okay. So when you're measuring things like wavelength, I forgot where we started this from. I'm sorry, that happens sometimes.
You're good, man. I like where this is going.
Oh yeah, talk about the definition of frequency. So the higher frequency you have something, we were talking about like revolutions per minute, the more frequently it happens per unit time.
Right.
And then you have wavelength, which that gets more into light and sound. We'll talk about that in a little bit. But for the most part, beginner part, frequency is just how often something occurs per unit time.
Okay.
Next is harmonics. Yeah, harmonics essentially it's just the study of sound. It has a lot to do with vibration, which vibration has a lot to do with frequency because again, those two are very interconnected. The higher the frequency, the bigger the vibration because frequency is measured in hertz. The bigger the hertz, the bigger the vibration, that kind of thing. So there are two official definitions of the harmonics, both of which are important. Harmonics is defined as an overtone accompanying a fundamental tone at a fixed interval, produced by a vibration of a string, which we'll talk about in a little bit because we're getting a little bit of string theory, which is fire.
Oh my god!
I know.
All right, keep going.
We're getting into the string theory a little bit, and column of air, etc., and an exact fraction of its length. Secondly, harmonics is described as a component frequency of an oscillation or wave. So, an oscillation is pretty much something like, let's say, for example, let's just look at the same graph, right? So with an oscillation, you have two different kind of points. Now, I know this is a really rough graph, and it's not ideal. But right up here at the top, you have 1/2 of a complete oscillation, okay?
Point the graph more at Cody.
Yeah. So at the top here, you have 1/2 of a complete oscillation. And then when you get back down to the trough here, that's one complete oscillation. So you've completed one full, depending on where you start, you can either start here. A lot of people start at the top and then just consider it from like peak to peak right there. So oscillations is essentially like when you complete a revolution of a frequency.
Okay.
So when we're talking about oscillations, it essentially boils back down to sound and vibration and frequency and things like that. If something's oscillating, that just means it's moving back and forth in a pattern. Like that's essentially what it means. It's just like
it's moving back and forth in the patterns like that, and oscillating state and frequency.
Like a sine wave, like how you see it goes like that. It's just whenever it completes its full thing, that's one oscillation. There's also resonance, which is sound resonance, which is defined as when one object vibrating at the same natural frequency of a second object forces that second object into vibrational motion. So let's say, for example, but let's say I were to shake the table hard enough. If I could manipulate the table enough to vibrate it quickly, the whole entire structure of the table itself would start to vibrate. Like the table itself, the molecular structure of the table would just begin to, slightly, ever so slightly, just move back and forth. So if you have a resonance, you have enough force onto something to make it vibrate.
Okay.
When we talk about the principles, it can get really deep, so we'll just start from the beginning and work our way out. So this is the part where I told you earlier it's going to kind of blow your mind a tiny bit. So first things first, I might skip this and come back to this. Actually.
Amaryllis.
I'm going to skip. I'm going to make it a circle. I'm going to make it a circle.
Okay.
So first things first, as humans, we have a intense connection to light. It starts with the sun. The sun is our main primary source of light, heat, energy.
Right.
There is, I think I just learned about this. The sun provides like 1 times 10 to the
Don't worry about the
9
details.
joules, something of energy per square meter. So if you were able to capture enough of the sun's like literally 1 square meter, like 1 meter by 1 meter square, you'd be able to power your entire house for an entire year.
1 meter?
Yeah, just 1 square meter. 1 meter by 1 meter. But the downside and the only thing that prevents us from being able to do that is...
It'll blow up.
Well, not that. is the atmosphere. Like with the atmosphere itself, it gets cloudy. The light gets scattered from the sun, so we're never really going to be able to efficiently capture all of the sun's constant that we can actually capture on Earth. But a lot of times, if we have solar panels and things like that, a lot of times solar panels, the issue with they're not very efficient. Like they do what they're supposed to. They convert sunlight into heat, which stores in its battery, which can create electricity, things like that. But they're not as effective as they could be. Right now, about the best solar panels that we have are about 40% effective. When realistically, in 100% effectivity, we could get like 1,300 kilowatts. It's like I said, my details are a little off, but it's okay. Good. But yeah, if we were able to capture the 100% efficiency of the sun, you could power all of everything you have for the entire year for one year, and I think that's.
And they only capture 40% of that.
Yeah.
That's interesting.
Yeah, it's one of those things where the technology isn't quite there yet. Yeah. Solar panels are not new. They've been around for a while, but they're still infant in their evolution, because they haven't, there has not been a bunch of significant progress made in the solar panel.
So for my senior project, interesting enough, just a little story. Mm-hmm. I actually pitched Corning Inc. in Wilmington, North Carolina.
Nice.
To try to install solar panels, and I had to do a whole presentation on how horrible our normal energy sources are for the environment and everything, and what they're contributing to the environment, which
we'll get into that too.
I presented to like a panel of engineers, and it was like my first time ever presenting in front of people.
Yeah.
That high status, and it was very interesting, but they didn't go for it because especially this was like 5-6 years ago now.
Yeah.
Where solar panels were definitely way less efficient than they are even now.
Mm-hmm. Oh, yeah.
So the return on investment was horrible.
Oh, yeah.
It was absolutely horrible, and they weren't going to do it, even though they had so much building space to put solar panels on top.
Yeah.
So
a lot of the issues that happen today are strictly like
economic.
Yeah, economic in the sense that when we use resources, we don't really have a way to recycle them.
Yeah.
We don't have a way. They're not renewable, like coal, fossil fuels, which oil isn't necessarily a renewable resource, because essentially what fossil fuels are, if you take something and you let it die and you put it in the ground and you let it stay there for about 1 million years, it will eventually turn into crude oil. Like the people that were buried in ancient Egypt, ancient Samaria, that's 30,000 years at most. I think that's still quite a bit high estimate, but a lot of times it takes a very, very long time for the bones and all that kind of stuff of the decay to break down enough to where you can use it as a fuel. So the issue with that is that they're not renewable, and honestly, they're the pure output of CO2 and a lot of the greenhouse gases that are in the atmosphere. CO2, surprisingly, water vapor. Water vapor is a greenhouse gas. Not many people realize it's a greenhouse gas. And water vapor itself contributes...
Water vapor?
Yeah, water vapor is a greenhouse gas. Now, it's not toxic. It's not toxic to people, but it is a greenhouse gas.
Okay.
And a lot of things that people don't realize is that water vapor in the atmosphere is super, super huge in the... if keeping the temperature regulator of the planet, pretty much. Like, the more water vapor you have in the atmosphere, the higher your temperature is going to be.
Interesting.
Which is wild because, if you think about it, you have the sun's rays coming down to the earth. They hit the earth. They bounce off. They get caught by greenhouse gases, which heat them up. And as you heat them up, you have steam, which gets hotter, all that kind of stuff. So eventually you'll have more water vapor in the air, more temperature. It's a gradual increase. But water vapor is a big component of temperature. That's pretty much.
I didn't even know that. So I heard too, like 400,000 years ago. This is like controversial climate change history presented by conservative sided politics. Mm-hmm. But about 400,000 years ago, the Sahara Desert was like covered in grass.
Yeah,
there was like goat farmers and shit.
Yeah,
and so like that aspect was that the Earth did warm up. Uh-huh. And there's, I guess, more. It sounds like there's more water vapor because it warmed up, and so the sea levels decreased, and there's more water in the atmosphere as it is.
Yeah,
and so it was warmer, and there were certain areas of the Earth that are now deserts were actually populated with life.
Because when you think about it, like
so, but does that mean now we're talking about how horrible it is with carbon and like, is it so bad that the Earth is increasing in temperature?
Only 6,000 years ago, the Sahara Desert was tropical.
6,000?
See, there you go.
Oh, well.
Because when you think about it, because to answer your direct question, the main the main problem that I feel like the Earth itself faces today is CO2 levels. And the reason being is because CO2 is a very difficult gas to get rid of. It's a very difficult gas to scrub. So when you have it trapped in the atmosphere, it's going to naturally create a stronger greenhouse gas effect. Like Venus has the strongest greenhouse gas effect in our solar system. And that's why its temperatures are through freaking roof.
Yeah, it's the hottest planet.
Yeah, it's hotter than Mercury, which is closer to the sun.
Yeah,
because of the greenhouse gas effect.
Mercury also doesn't really have an atmosphere.
Yeah, it has it's closer in relation to the moon.
Right.
Yeah, with some geographical activity, but still.
Yeah, and that's so interesting. I think Venus, Venus is like the sister of Earth because it's like about the same size, but then I don't think Earth can get like Venus though. Like at the end of the day, the greenhouse gases increase. I think Venus is has a whole different breed, depending on what.
The reason that Venus is the way it is because it has so much higher volcanic activity.
Right.
Like there's plumes constantly being put into the atmosphere. So in theory, it could happen if we had the volcanic activity level of Venus, but it's not something that we'll ever see.
Yeah.
I hope.
Yeah.
So,
would you want to steer this conversation more towards back to frequencies?
Yeah, that's what I was about to come back.
Oh, sorry,
my
bad.
So essentially, the sun is our main source of light, a main source of energy, main source of heat, and we have a very interpersonal relationship with not just our sun, but stars in general.
Okay.
So at the beginning of the universe, when the Big Bang happened, there were not many elements in the universe except for hydrogen, helium, and a little bit of lithium. It was predominantly hydrogen gas, helium gas, things like that. So what happens is hydrogen gas, even if it's still a gas, it still is matter, okay? So there's dust particles, gas particles, all that kind of stuff. Eventually, due to gravity, because gravity kind of always wants to make things come together, eventually due to gravity, those particles are going to start to come together, okay? And at a certain point, the more it starts to accrue matter, the more heavy it's going to get. And due to the conservation of angular momentum, once it gets enough matter, it's going to start spinning. And eventually, once it spins for long enough, because I actually have this written down. Once it spins for long enough and gets hot enough, it will create what's called a protostar. A protostar essentially is this little baby star. It's not classified enough yet to be a star, because a star is classified as something that can create nuclear fusion. But
really,
yeah,
I didn't know that.
Yeah, a star it's classified when the core of the star can undergo nuclear fusion. That's when it's classified as a star. So you have protostars, and around the protostar. Hey Dylan, would you mind? Could you potentially like bring up an image of the protostar just so I can kind of like just type up protostar, that way it will make a little more sense.
Yeah, both of them there.
Yeah. So a protostar, it's a mass. It's a pretty large mass because it still is becoming a star. It's not the typical mass that you would expect a star to be, but it is a mass, and around it, it's kind of got like a flat accretion disk. Okay, which is like that. So in the middle of that is your protostar. And then around the outside of it, you have your accretion disk of dust, rock, all kinds of different. Well, rock. We'll talk about rock in a minute. But like you have dust and gas and all kinds of different stuff. Eventually, when that star gets hot enough, it will undergo nuclear fusion. When it undergoes nuclear fusion, it will have a significantly big blast, and it will send that material that's around it scattered out to as far as it will go. Now, this ties back into us because the same principle happened with our star. Now, what ends up happening is that when that gas gets sent far enough away from the star, depending on how far away distance-wise it gets, you can either, it can freeze and become water, it can become ice, things like that. But for the most part, that's how planets are formed, because once it sends the matter far enough away, eventually that matter is going to start finding friends, and it's going to start getting back together. It's going to start clumping back together, and it will create, your first few stars, your planets, or not stars. I'm sorry. It'll create your first few planets. So where this idea comes from is that when stars are born, and nuclear fusion, what it is, excuse me, sorry about that. What nuclear fusion is, essentially, is taking hydrogen atoms and pretty much smashing them together at a really, really high velocity to create heavier elements, which helium, nitrogen, oxygen, carbon,
iron,
things like that. Yeah, iron too. Yeah,
Iron's a big one.
Yeah, iron is more in the supernova. It's towards the tail end.
Okay.
But yeah, that too. So that plays a really, really big part, because when you start to create those heavier elements inside the core of the star, there is a life cycle for everything. There's a life cycle for humans. There's a life cycle for planets. There's a life cycle for stars. There's everything. It's just the circle of life. Things will be born. Things will die. It's just the way it is. It'd be like that. So
I love that. The circle of life, and everything has one.
Yeah.
Everything has one.
I
don't think a lot of people really think about that.
Yeah.
Everything.
Yeah.
Every single thing out there has a circle of life.
Carpe diem.
It's going to start and end at some point.
Mm-hmm. So when you think about it, at the end of the day, when it gradually starts to make more and more heavy elements, so it goes from hydrogen to helium, into what's next, boron, and then to carbon, silicon, it will eventually start to make heavy and heavier elements as it starts to react more with the elements that are inside there. Because once it's a complicated process, but once all the atoms smash together, it kind of creates a new element, because you'll have protons and neutrons. Anyway, still. So when a star dies, it does one of two things. It typically goes supernova, but it will either turn into what's called a neutrino star or a black hole, depending on the size and the mass of the star. Now, the smaller mass stars will typically go neutrino star, because they're not quite dense enough to create a black hole. Neutrino is just a type of particle. Neutrons. I'm sorry, not a neutrino. I'm sorry, not a neutrino for any science geeks watching. A neutron star.
A neutron star. I was about to say, wait, neutrino is like that's a certain
neutrino
type of
is a different type of particle. Yes, I'm sorry.
That's a different type of particle.
Neutron star. My apologies to all the science fans out there. So it will create a neutron star or a black hole, depending on, again, the size and the mass of the star. So, but during supernova, it kind of explodes, and it sends everything that it's created inside of the core out into the outer part of the atmosphere, or not atmosphere. I'm sorry, outer part of the universe. Eventually, those particles will find more friends. They will start to like that. So supernova, that's the remnants of the.
Save the image too, Dylan.
Yeah, there you go. So when stars go supernova, they send everything that they've created out into the universe in all sorts of different directions. Eventually, those particles will find friends. They will find more matter. They will find things to accrete again. They will find ways to actually come back together and create more stars. And when that happens, you now have stars that have heavier elements inside of them. And with our star predominantly, we have things like iron, nickel, carbon, nitrogen, all those kind of things. So what ends up happening is that due to the first law of thermodynamics, energy cannot be created or destroyed. However, it can be transferred. So it can be transferred from so let's say, for example, I'm holding my marker up here, right? It has potential energy, gravitational potential energy, and then if I drop it, it has kinetic energy. And then at a certain point, just different example, if I have my hands here like this,
it changed from a different potential energy to kinetic energy.
Yeah.
So there was a different type of energy there first.
Yes. So
interesting.
At here, it has 100% potential, 0% kinetic, 100% kinetic, 0% potential, and then at the bottom again, 100% potential.
Just saying, Rocket City Podcast. That's very important to note. Keep going.
So with that in mind, when energy transforms, it can go in different ways. There's a whole bunch of different types of energy. You have thermal radiation. You have electromagnetic radiation. You have again, gravitational potential energy, kinetic, all sorts of different types of energy. And when those things occur, what ends up happening is that when you have those heavier elements around the planets or in the planets, such as Earth, what ends up happening is that it kind of builds those building blocks for life, right?
Yeah.
What's really cool, I learned this past semester, is that a very, very large component of nitrogen is contributed to lightning in the atmosphere. So when the Earth was really, really young, lightning was there was so
there's more nitrogen in the atmosphere.
Yeah. Oh yeah.
Yeah. When
there's like 70%.
So there's more lightning and things.
So when the Earth was really young, like super, super young Earth, it was very, very violent, super like kind of a living hell. You had
intense volcanic activity,
just magma
storms,
everywhere.
magma,
it was
lightning,
literally
hell.
a nightmare. You would not want to be there. It's just one of those things where that's just what it is. And eventually, at a certain point, their electrical charges in the atmosphere started to pick up, and lightning started to strike the ground. Well, when it did, there's a component of nitrogen. There's a component of lightning that carries nitrogen that struck the ground, which is a very big component of having nitrogen in our Earth, which is, again, a major building block to our life because, again, the air that we breathe is 78% nitrogen. So we don't just breathe pure oxygen because we would be loopy all the time. Anyway, so with all that in mind, I know there was a really long, convoluted way.
Yeah, I
of
just
saying
want
things.
to tell the audience that Sean Heflin, when you talk to him, he is the most down to earth guy, and you would never know he knows all this stuff. And I just want to conclude that you just summed up you're summing up how life comes from stars.
Yeah.
Well, our particles and how we come from stars and how from the start of the Big Bang, and that explosion after explosion after explosion of supernovas, and it creating new elements because the start of the Big Bang, it's hydrogen and helium, correct?
Yep.
And from hydrogen and helium, we got all the other elements out there. So we come from stars.
Yes.
And that's basically what you just summed up. And I loved how you did it because I don't think I could ever have memorized all that. And I loved how you did that. And you just don't come off as that type of guy. and so you were impressing me, sir.
Thank you.
As the Sean Heflin who I know and how passionate you are about the subject. Anyway, keep going. We're talking about lightning.
You summed it up, man. Honestly, that's where I was going, is that we are made from the remnants of dead stars. Our physical bodies are made up of the atoms of stars that existed billions of years before us. Also, slight fun fact, I don't know if you guys saw this recently. It's really, really cool. I think it was either this week or last week, very, very recently. Hubble recently saw the furthest galaxy clusters that we've ever seen.
I've heard about that. Yeah.
They saw the galaxy clusters from when from when the universe was 680 million years old. Keep in mind the age of the universe is 14.7 billion years old. So we're looking back 14.1 billion years, which is awesome to me because technically you're time traveling, which is rad. But a lot of it has to do with like the magnification of Hubble, which is really cool. But anyway.
I want to throw some controversial evidence in there. Hopefully this doesn't take off your subject where you're at hand. They just found a star. Apparently, they just found a star that might be older than the universe, than the Big Bang Theory.
Really?
So the Big Bang Theory might be disproven. It's not necessarily true. Okay. I don't know too much about the article. Dylan could pull it up. But they think that in the star in its solar system has like the remnants, like it has very little. It doesn't have as many elements as most other solar systems. That's how they found out. They're like, oh, wow, this star has not as many of the elements as the other ones. And they're like, holy cow, it might be older than the Big Bang. And Dylan's just pulling it up right now. Yeah. Hubble.
That was from 2018, but there was something recently, like last week.
Oh, there's something recently. Well, this might be the star that I'm talking about. That might be older than the Big Bang.
Yeah. I'll get you.
Which I'm not claiming that the Big Bang theory is disproven. That because if there's a star older than the Big Bang, that doesn't necessarily mean it disproves the Big Bang.
I'm going to. I promise you. I promise you. In this talk, we're going to talk about Big Bang and how I don't necessarily believe in it. I believe in Big Bang.
Oh my gosh!
But there is a principle behind it that it's more important. I'm going to talk about that next. I'm going to finish this up first, and then we're going to talk about that next.
All right, go.
Okay. So the reason I bring that up, the reason I talk about the stars and how interconnected we are to light, is because as we exist, you and I, and Dylan over there, as we exist,
He's in control. Keep going.
As we exist, we have two bodies. Okay, we have our physical body, carbon, nitrogen, oxygen, silicon, whatever, and then we have what's called a light body, which is inside of us, which is often referred to as the soul. We have, it's typically just energy. Now, this idea can help explain the human consciousness, pretty much. Because there's not very much that separates us between animals. Like when you think about animals in the wild, you have cheetahs, you have giraffes, and whatever. You have all sorts of different kind of stuff. But what separates us between us and them, their primary instinct is eat, survive, breed, die. Cool? Okay. Whereas we as human beings, oh wow, that is it. Look at there.
Look at that. Okay.
Is
So
a
don't-
metal-poor subgiant star about 200. Wow.
Away from the Earth constellation.
So the star's name is HD 140283.
Yeah.
So
Wow, that's wild.
they're saying that's the star that's older than the Big Bang. Is there anything else on it? Can you look down and go
Yeah,
down?
I'm
a
sure
little?
there is, but
Yeah, that was
You-
recent. That was like October.
Yeah. That's why I was like, when I saw it come up in my feed, I was like, oh my god, there might be a star that's older than Big Bang.
That's sincerely wild.
That
Also-
might help your theory.
No, that actually very well might.
Ho ho ho!
So also, I think
excited.
Beetlejuice might be going supernova soon.
Beetlejuice might be going supernova.
I think so,
soon?
'cause
They're
it's been
thinking
getting
about that?
super
They're
dim.
talking about that? Wow.
Because they've been talking about how dim Beetlejuice has been getting over the past few months. But back to what I was indicating here.
Uh-huh.
So we are so interconnected with light because technically we are made of light. We are made, like I said, we are literally bags of meat that are encompassed by a human consciousness. The difference between us and animals, we have the ability to ask how, why, what is this, where are we from, what am I, who am I? Whereas again, animals eat, breed, survive. So with that in mind, we have different principles that come with us. We have survival instincts. We have energy pools inside of us that go from the base of our spine all the way up to the crown of our head. I'm not going to get too deep into that because that's not necessarily something that, super important. But just know that, like, you have your survival instincts, then you have, like, sexual energy instincts, then you have, like, your ego, then your heart, your throat, which is intuition, then you have your third eye, and then you have the crown of your head.
Third eye.
Yeah. So third eye is like psychic
or-
powers and
Okay.
yeah, it has to do with it, things like that. But still,
Prefrontal cortex.
Yeah.
Okay,
yeah.
gotcha.
Um,
That seems more scientific.
Yeah. So what's really cool is that in our brain, in the direct center, like where I can't point to it because I can't point to the center, but in the center of our brain, like center of mass, center of gravity, there is a specific gland called the pineal gland, which a lot of people have overlooked, and science has not really paid much attention to it. But this is kind of the idea behind human consciousness, and it's the pineal gland itself kind of helps you tap into your human nature and who you are, kind of that kind of thing. But so, with all that being said in mind, our human bodies are just vessels for our light bodies, which is who our true self. This is, goes back into divine source, which goes into consciousness and all this kind of stuff. But
Would you say this topic is very controversial too? Because I
controversial?
don't think a lot of people realize this, and this is what I understand from
Yeah.
it in my separation from the church in a
Yeah.
way, because I understood this.
Yeah.
Because I was like, okay, there's a lot of frequencies and energy being
Yes.
played out, where energy is neither created nor destroyed.
Yeah.
And we don't, and science has yet to uncover everything of the brain. And so they don't understand how the energy really plays into that. And
Yeah.
we're going to discover more along the way. And
Yeah.
the way you're describing it is great, I think, for what's helping me
Yeah.
in my journey almost understand how we function with the world. And I think a lot of people don't understand this because energy is underplayed. Energy is neither created nor
Sincerely.
destroyed.
Yes.
When you die, the energy in your body goes into the ground. That energy is transferred. That can prove an existence of some form of heaven in a way. Maybe it's just transferred into the ground, but that if you really look at it at a beautiful scale, transferred into the ground grows trees. A bird comes and eats the berries off those, or eats part of that tree, or a monkey eats a banana off that tree. That energy is then put into that body. Then they have kids.
Yep.
The monkey has kids. I'm not rolling with the monkey and the ape. And then that monkey plays with,
Yeah.
and that energy is just,
Yeah.
it's always flowing.
Right.
But if you think about it in this crazy ways where it's just always flowing through everything, and that is so beautiful. And you
Right.
don't even understand that. You don't even think about that
Exactly.
day to day.
That's the thing, is that I've
So-
noticed that a lot of people don't really take the time to just stop and be with themselves. Like a lot of people, it's hard. I recognize I openly admit it's very hard to
very hard.
to stop and say, okay, I want to spend some time with me. I want to understand who I am, because you've got bills and kids and all sorts of different responsibilities to take care of. So, but a big part of what this is that the light source from inside of us, so there's a really interesting thing. So, if you had to put what's the most common phrase you hear people say when they're on their deathbed, like going to death? What do they say they see?
What they see?
Yeah,
they see
going into like
they see the light.
The light, right?
The light, yeah.
So a lot of times,
at the same time.
So a lot of times when people say, "Oh, I see a white light," I'm going into the light. That's kind of the idea behind divine, like not intervention. Well, I guess intervention, yeah, like divine existence, really, because it's a piece of all of us. Everything that, no matter what you may think, not what you were saying, like no matter how small of a scale you may think it be, everything is connected. Everything is connected to each other in some sort of way. We have relations to trees. We have relations to the human DNA shares, like, corresponds with the banana. So
yeah.
So everything is connected in a way that, when you think about it, the light source that we emanate from comes from that. So this all ties back into frequency, because a lot of times human interaction with frequency goes right under the table. People don't understand, like, how much the outside world completely influences you, because people think like, oh, I just kind of need, like, it's just me experiencing these. Like, no, there's more at hand here. Like, yeah, you might think it's you, but I promise you it's not, because like different color to the eyes has different wavelengths. So like you have the visible spectrum, which goes from red, yellow, or red, orange, yellow, green, blue, violet to UV, and then back here you have IR, infrared, things like that. The different wavelengths of color, like I said, frequency and wavelength are inversely proportional. So the higher the frequency, the lower the wavelength. The higher the wavelength, the lower the frequency.
Right.
So you have red light, which has a super, super long wavelength, super low frequency. It's much easier to our eyes to comprehend, and it's much easier. Different colors put you in different moods. Things like red can be like anger and love and hunger. A lot of times you don't recognize it, but a lot of times, like, there you go. This was from earlier. This is the pineal gland, but there you go. It's right there.
Sorry,
but
we didn't see that, Dylan.
Yeah, my bad. I didn't see
Anyway.
that. A lot of times, fast food restaurants will try to advertise to you with the colors, because like McDonald's, red and yellow. You have typically a lot of red, orange type of colors. In
Snapchat uses yellow for marketing purposes. Mm-hmm. Apparently, yellow is a really good color for that.
Yeah, yellow is a lot of self-esteem. Yellow can help.
Interesting.
Yeah, it can help boost a lot of self. Like, it's in the whole technology scale.
Think about that. Colors manipulate you, and you have no idea. You don't even think about that on a daily basis. I know when a girl wears red, that usually means like love, and I don't know if you want more.
Yes.
Of that cigar. Uh-huh. We're smoking a cigar, rum flavored. It's delicious, but colors, man, really do a lot to you, and we don't even realize that. Your shirt, by the way, has so many colors on it.
Yeah, right. So this is I got this shirt at a music festival I went to a little while back, and I'm not going to answer that right now. So this shirt goes back to, like I said, this is just something that I personally enjoy because I like the colors in it. But like, like you have different colors that do different things to you, which gets into technology, things like that.
Yeah. Because
no matter where you go, blue light is everywhere.
Blue light is very significant. I think a lot of people love blue, the color blue, and it represents life in a way, because like the sky is blue, but that's because of our oceans. To my knowledge,
the
I might be
blue
wrong.
light is technically the reason our sky is blue is due to the scattering of light emitted from the sun, because the sun's light is emitted white, and then our atmosphere scatters a lot of the red light, so we don't see. That's why we have red sunrises and sunsets, because
makes sense.
It's less scattered at that point. But so blue light itself is very influential in human day-to-day life, because no matter where you go, it's always going to be there. Whether it's sunlight, now in our society that we live in now, TV screens, phone screens, tablets, anything that you interact with throughout, monitors, anything you interact with throughout the day is emitting blue light at a specific frequency.
Right.
Now, here's the deal.
I know like 4K television emits like yellow light and stuff like
which
that.
is probably
which
is a lot better for you. But
it is a lot better for us.
oh yeah,
Yellow. Let's go yellow.
all right, because that's
Anyway.
why
Hey, forget that though. Go back to what you were just talking about.
our eyes are actually really, really bad at blocking blue light. So when you're looking at a TV or a phone, look, our phone is probably, I'd say, the biggest the biggest component, because we use our phones
All
all
the time.
the time. So as you're on your phone so much, that does a lot of damage to your eyes, because our eyes are not designed to block a lot of blue light. Like we have natural blue light, things like the atmosphere, and I guess that's really, honestly, I don't know of many other natural cases of blue, because like you have man-made cases of blue, but like there's no blue raspberry is fake. It doesn't exist.
What? Blue raspberry?
Blue
that
raspberry does not exist.
Okay.
Raspberries exist, but
what about
blue
the
raspberry
ocean?
does
The
not.
ocean.
The ocean's technically clear.
That's
it
true.
appears
That's
to be
true.
blue because of the reflected light from that.
Okay,
atmosphere.
yeah, that makes sense.
So-
Blueberries.
What about-
Okay, I'll give you that one. Yes,
what about,
blueberries.
what about the blue in like your background right now?
So actually, fun fact: what you're looking at behind me, this space image, a lot of times will be composite pictures of multiple different types of telescopes. So you have Hubble telescope, which is looking at the optical frequency, optical wavelength of light. Then you have Spitzer, which looks at, I think, UV or IR. It looks at a different frequency of light. And then you have other telescopes that, let's just say, for example, you have a telescope looking at UV, IR, and optical, respectively. At a certain point, they're all going to take an image of the same piece of sky, and once they all take that same image, they will slap them together, and they will get the colors that you see behind me. So technically, it's not real. It exists. You can see it.
Right.
But
I
if
heard
you
that
were
before.
there in person, it would just appear to be black with the stars. Like you would see the light emitted from the stars, but you would not see the colors behind you, because that's just your eyes can't see IR.
Do you
can't
know
see
that
UV.
nebula? By chance? Not off the top of your head.
No, it's not Eagle, is it?
I'm not sure. I can't remember exactly. We'd have to look it back up.
Yeah, I don't know. Like,
You say Eagle?
yeah, Eagle Nebula is like the Pillars of Creation, like the big like the majestic.
Jesus
image.
Christ, Sean, you know so much more than I thought. Your IQ must be like fucking off the charts.
Don't flatter. I'm literally a bag of rocks. I just have to read books.
Have you ever took an IQ test?
Mm-mm.
You should
'Cause
do it.
They're
Just
dumb.
check it out.
IQ test does not
They
test your
are
IQ.
okay. I see your point there. So they only go so far, right? But like it's good to know yourself a little.
Mm-hmm.
And I think I did not realize how much you know. And
Thank you.
I think you should take an IQ test just to see. I took one just to see how I was, and then but with you, you got a point though, because it doesn't measure like emotional intelligence, stuff like that. Anyway,
there's a
back
lot
to
of factors
frequency.
So, I'm sorry. We were talking about okay. So, to kind of get back into it, so I'll just talk a little bit about, so the things that go up your inner spine are called chakras. Okay. Now this is kind of
Chakras?
Yeah, chakras.
Chakras. This is Eastern philosophy.
Yeah,
and
Eastern
stuff
philosophy,
like that.
Eastern religion. I'm not going to say I subscribe or don't subscribe. I'm not saying that I do or don't, but I'm just giving you information of what it is. Okay.
I appreciate that.
Yeah, of course.
Because you combine, I love how you're combining all of it. You're combining all of it, which I love. Anyway,
So at the base of our spine, we have our root, which is our physical security. It's the color red. Security is anger, red, violence. Blah, blah, blah. So you have red. Next is orange, which is your everybody in planet Earth. I imagine that since this is controversial, people will know what's going on happening in here. Orange is your sexual energy. It's how you permit or how you project your energy onto people. Yellow is your ego, is your personality, who you are, and then it kind of separates. Green is your heart. So
green is your heart.
Green is your
I think
heart.
a lot of people think red is your heart. But
yeah,
it's green.
you would imagine so, but like red has a lot of connotations to it. If you were to sit in a room for a while with just red light, your brain would just kind of naturally progress to different type of ideas. Well, red curtains are different. You can differentiate between white light bouncing off of red curtains and just pure red light. But yeah, green is your heart. Blue
Switch to that.
blue is your throat. it's kind of like your truth, like you speak the truth. And then your third eye is like kind of pink purple, and then the crown of your head, which is conveniently the crown chakra, is violet purple, that kind of thing, which is your connection to who you are as a person.
Okay.
Now all this ties back in together because it kind of creates what's called the toroidal field around you, which I'm gonna write that down because that gets into magnetic energy.
Holy cow, man! You are.
I told you. I told you I was coming, man.
Freaking amazing! I love this.
So
you're connecting it all. And
man.
I think a lot of us can vibe with this.
I hope so. I really do, because this is stuff that I personally enjoy. So as long as just take it with a grain of salt, do your own research. But like, so we have a toroidal energy field, which kind of like, yeah. So that's the system right there.
That's right. I've seen that picture before.
Yeah.
Actually.
So it starts at the base of your spine and kind of goes up the body. Some people will argue that there's more than 7. Some people say that there's 13. The one that's easiest for me to understand is 7, because I'm, again, dumb. So,
no, you're not.
This is the easiest for me to pick out. Like it even says there, basic trust, security, creativity, power, love, communication, awareness, all that kind of stuff.
Dylan, click on that one so we can read all.
And the bottom, there you go, that one right there. So wisdom. So wisdom right here would be your solar plexus right here in the middle, right in your gut. Like you ever get like a gut feeling like, this isn't right. It's intuition, wisdom, things like that.
Okay, that makes sense.
So your toroidal energy field. So do you know what the magnetic energy field of the Earth looks like?
Yeah, it's crazy.
Yeah.
But like it's really effective in protecting us from more radiation.
Dylan, would you do me a huge favor, please? Would you pull out the magnetic energy field of the Earth, please? Thank you. So
there's gonna be a lot of images in this episode.
Yeah, it's gonna make sense. It's gonna make more sense once you see it. I'll kind of tie them both back together. But the magnetic energy field of the Earth is very similar to the toroidal energy field of humans. It's shaped the same way.
Shaped the same way?
It's shaped the same way.
What?
Mm-hmm.
That you gotta understand, if it's shaped the same way as the magnetic field of the Earth,
so
that's insane.
The thing about it is that, look, that one right there, that one right there, below it, that one right there. That's what the magnetic energy field of the Earth looks like. The toroidal energy field of humans looks almost exactly the same as that. Except, again, it's coming out of our head and kind of circling in through our spine. It kind of does a whole cycle thing. So with that in mind, toroidal energy.
What you got?
Yeah, okay. So they flow very similarly. Like I said, everything is... Oh, that's what I was going to go with. Okay. So in mathematics, in nature, there's what's called the Fibonacci sequence. Essentially, this is something that I have heard of, and I'm familiar with it, but I'm not too sure of the details, and I'm terribly sorry.
That's fine.
Because, again, this one's a little bit more complex. I think it's like 1.6 times the area of the previous shape. Yeah. So will you look at the image really quick of it? It'll make more sense. Like, yeah. So it's just a series of numbers.
Okay.
I found out by adding the previous 2. So what's going to happen is
I've seen that before.
Yeah.
What's that about?
So Fibonacci sequence is everywhere in nature. You see it in things like seashells.
Is this the golden rule?
Yeah, it's the golden rule.
Okay,
it's the golden rule.
The Fibonacci sequence is the golden rule.
It's the same thing. Yeah, they're exactly the same thing. So you have seashells, you have flowers, you have not fish, but like crustaceans, like I said seashells, I'm sorry. But yeah, there's multiple different types of examples of the Fibonacci sequence, and all this kind of ties back into divine creation, which kind of ties back again to us being sources of light. All of this has to do with just frequency and vibration, because again, each of the different colors of the spectrum can help you deal with different things that you're encountering in your life. If you need a boost of security, put yourself in some red light. If you need a boost of confidence, get out in the sun. There's a lot of different things, but the main part about it is how humans interact with color, how we interact with different types of vibrations, frequencies, all kind of different things. Because again, this kind of ties into things like music. Every kind of music, no matter what you listen to, no matter what it is, vibrates at a very specific frequency. Now, each individual song, I'm not going to break it down because I have no idea what every individual song vibrates at. But there are certain songs that are called binaural beats, They resonate at a very specific frequency. Things like 344 hertz. Yeah.
Oh my god.
There you go. There's a Milky Way right there. Look at that.
Yeah.
So like
is that the frequency in the Milky Way?
that is a Fibonacci sequence.
Hole in the Milky Way.
Yeah. The Milky Way. Just wait. I'm gonna blow your mind a little bit more.
You're about to kill me, dude.
I'm about to blow your mind a little more.
Can I go back one sec before?
Yeah, what's up?
Here,
Go ahead.
you
I'm
get
sorry.
some
Don't let
nicotine.
me interact.
No. You keep on that thought. Keep that nicotine on you. So, one thing to jump back where you said like, okay, when you go out and walk around, it builds up your confidence because you're in Mother Nature. That's very big because guess what? Bill Gates does an hour of walking a day. If one of the richest men in the world does an hour walking a day, I just want to say that's significant. That's very significant in a pattern of living a very good life. Mm-hmm. So
because then you have
all
sorts of different vibrations at that point.
Right, right. So that's very important to think about.
Get out in nature, man. Connect back with who
I've been
with.
Yeah, and that I will say when I was living in the woods, it was a previous job. I was in the conservation corps, living in the woods for about 4 months. Contract I had, and I will say, without the dopamine effect of having your cell phone and a lot of other things. Dude. Oh my God, dopamine blocks you so much of so many things. I will say I was happier at that point in my life than I am now. And that was only like 2-3 years ago.
Because you remove yourself from the need. Because a lot of times the addiction to technology is when you post something on Instagram, you get a like, right? It's another hit of dopamine. And then you get more likes and more likes and more likes. You're addicted to your phone, but here's the deal. Remember, your phone is emitting blue light, so it's actively destroying you because you're addicted to your thing that's making you happy that is actively hurting you because your eyes are not designed for that type of frequency of light.
They say it's the equivalent of doing crack cocaine and all the worst drugs ever.
Dopamine is more addictive than cocaine.
That is insane.
So is sugar, by the way.
Yeah. Sugar is also more addicting than cocaine, which is hilarious. And that's just a message to stay off your phones even more. A little bit at least.
See, here's the thing. Phones and technology are amazing tools, but don't let them swallow you because they will. And it's not their fault. I mean, it's the people who established them there and people who put them in place, but still at that point. Also, he pulled up a really cool image. Is that a seashell?
That's a seashell.
Yeah, so that's a seashell.
With the Fibonacci. Am I saying it right?
Fibonacci? Yeah, Fibonacci.
Fibonacci sequence.
So what this ties back into is that everything in nature, or most things in nature, you can tie back to this kind of sequence. And if something even really cool is ancient Greek like architecture, like the Parthenon. The Parthenon is designed with the Fibonacci sequence. Art, Da Vinci was super, like all of the classic Renaissance art everybody back then was so mathematically inclined. There's a reason why that art is still prevalent today. Like there's so many artists that just
you're seeing the Greeks like the Parthenax?
Yeah, the Parthenon was
sorry.
Yeah, the Parthenon was designed mathematically.
Wow.
I have found rocks that have the Fibonacci sequence going on the backside of them.
That's awesome, dude. Look at
all
that.
of these.
Oh
all of these.
My
it's all Fibonacci.
God.
But yeah, man, like art, music, because even that music is math. Like what makes really good music, Bach, Beethoven. Like it might be a little boring in today's standards, but when you listen to it, like it hits at a certain frequency because mathematically it's designed to do that.
I think the point, too, is that if there's a pattern recognized here in any way in nature and science, recognizing a pattern, that means it's significant.
Yeah.
This is so mind-blowing to me because I think a lot of people just walk around in life and they don't realize.
They don't understand.
They
really don't.
They don't realize the patterns in life. And the patterns prove so much. It can prove to you a creator. Mm-hmm. It can prove to you that there's something else to look forward to in the afterlife.
Yep.
It can prove to you so many things. It's a spiritual aspect.
Yes. And you know what's wild is that now I'm gonna get into something that you were.
Closer.
Now I'm gonna get into something that I feel like you probably been waiting on.
Oh,
I'm gonna get into Big Bang.
Oh, Big Bang.
Okay. So, personally, I feel like Big Bang is half the equation. What I personally believe in is called Big Bounce. Now, I'm going to draw it for you because this is important.
We're coining this right now. The Big Bounce.
The Big Bounce theory.
The Big Bounce theory by Sean Heflin.
It's not by me. I did not coin this theory.
Oh,
This
you did
theory
not?
existed before I did. I just
Shoot,
happened to
okay.
subscribe to it.
Okay.
I don't want to take credit because it's not my theory to claim. Hang on. Let me do this a little bit better. Let me draw something better. Sorry.
Make sure when you do hold up the whiteboard, you're gonna hold it at Cody. If you hold it right at the camera, the light will pick it up and there'll be a big glare.
Okay.
So
I'll hold it at
Cool.
Cody. Got it. Okay. So you have Big Bang here. Okay, it expands outward. The universe expands outward until a certain point, until it crunches back down on itself. Because again, the universe is expanding at an accelerating rate. So there's only so much you can expand before you start to overpower gravity. And at a certain point, once you reach that point, it's like velocity. When you throw something in the air, and at a very instantaneous spot, its velocity will be 0. So at a certain point, the universe of the velocity's acceleration, will stop. It will be 0, and then eventually gravity will start to come back, and it'll start to win. So it'll start to contract back on itself. Okay, and then what's going to happen is that as it reaches a point of singularity, it'll expand back out and do the same thing over and over and over and over. But here's the cool thing. Let me show you something else. Let me show you.
And
one more thing.
that's the sign of infinity.
Yes, it is. But let me show you something
That
else.
kills me.
Let me show you one more thing.
Oh my god.
That's important. That's a very important
I
idea.
kind of wish I went down the path of being an engineer to learn more physics like you, but I don't know if I could understand this.
This is a very, very crude drawing, but
I think I've seen this.
what does this remind you of?
DNA.
Yeah?
DNA. Definitely the
double helix. Yeah. So here's my philosophy. Here's my personal philosophy. Yes.
Show again towards the camera, towards me.
Here is my personal philosophy.
Okay.
Okay?
The bounce theory.
Yes, Big Bounce theory.
Big bounce theory.
When you think about the scale of the universe and how big everything actually is, and corresponding to how infinitesimally small we are in relation to it, when you think about it, this DNA, this Big Bounce theory resembles DNA and double helix almost completely. It kind of explains things like deja vu, like, oh, hey, I've seen this before. There's a reason for that, because you may have. The Big Bounce theory indicates that things are cyclical. The universe is cyclical. Everything that either is or was will always be. It's kind of the idea behind divine creation. Now, here's the cool part. This is just our universe. Okay? Now, I also subscribe to the multiverse theory, indicating that there are an infinite amount of universes. Okay? So if you have an infinite, or not an infinite, but a significantly large amount of double helix, you can create a person. So my idea behind this is that our universe might be the DNA strands of our divine creator.
Oh, you just killed me.
And
You
we
Killed me. You totally just killed me.
and we are a part of the atomic structure part of creating that.
And who created these theories? Like the other physicists figured this out beforehand?
Big Bounce theory is just a theory. I mean, again, there's no way of us ever knowing, because I say that. What's really cool, I'm going to talk about this in a second. Let me write this down so I don't remember it. I'm going to talk about
anything in science is proven through certain patterns in mathematics. And
So-
the fact that a lot of the basis of all these theories seem to be proven by mathematics.
There you go. I'm not quite sure. What is this image about?
Sumerian
Yeah, Samaria.
Sumeria, who apparently a lot of people don't know, which I wish they taught in world history.
Oh, yeah, I have
back
Sumerian
then.
history here, too.
Oh,
Yeah.
God, you do? Jesus.
If you want to talk about Sumerians, I can talk about
That's
it.
them
Oh.
drawing that shape right there in
Yeah.
the middle.
Yeah.
Back
Oh, whoa. They
Yeah.
are drawing the double helix kind of deal. Okay, I'm glad you
6,000
pulled that
years
up.
ago.
6,000 years ago. So, ancient Sumeria, for a lot of you that don't know, I think a lot of people push this past.
Super overlook.
They actually talked about in a lot of their tablets and a lot of their ancient scripture that they were put here by other beings to mine for gold.
Yep.
And a lot of their scriptures, which you just saw, that's a double helix, or what you just saw, and some other images that you can look into are that they even predicted that there was 8-9 planets.
Yeah.
Where there's these
Oh, yeah.
little dots around.
Mhm.
Like that goes to ancient civilizations possibly knowing more than we thought they did, and that they had possibly even more advanced technology. Super controversial, this whole episode.
So a lot of what I believe ancient Sumeria, the reason that I feel like, yeah, there you go, that exact thing right there.
That's it.
That's about
Boom.
Nibiru, Planet 9, that kind of thing.
Yeah, Planet 9.
A lot of what I believe about Sumeria is that, personally, 100% personally, I think that if we did not have the distractions that we have today, social media, reality TV shows, like just pure garbage. Literally, our brains are being filled with. If we didn't have that,
That's why I don't watch Netflix, do video games anymore. Games anymore. Anyway.
So we eventually could be back in an intellectual level compared to the Sumerians, because the Sumerians knew things so much. They were able to predict astronomical events down to a very precise T. A lot of times when people say like, oh, hey, because you had the Sumerians, then you had like the Egyptians, then you had the Aztecs, then you had all these civilizations come up, and then you had the Dark Ages. Also, the burning of the Library of Alexandria was a worldwide travesty. Shout out to the Library of Alexandria.
Yeah, I hate that, because they even talked about that. It's possible that the Bible passed through that, which is even the burning happened. I can't remember. We mentioned in the last episode.
It was from Nero. I think Nero was responsible because he burned Rome.
Okay, yeah. And it just killed so much of what we probably knew. And God, I mean, people are talking about even like the one mathematician inventing steam engines.
Yeah.
And that's like 2,000, 3,000 years ago.
Wow, that's wild.
Yeah, it's so controversial of a topic. However, it's brought up. It's like, oh my God, like that could have happened.
It makes sense, though. It makes sense.
Yeah. What you bring up now?
there you
48 BC. 48 BC. The burning
Caesar.
of
No wonder he got stabbed.
Caesar?
27 times.
Caesar burned it?
No wonder he got stabbed.
I didn't know that.
Wait,
Didn't he? How many times did he get stabbed? Look that up.
27.
Oh, okay, I was about to say,
27 times, respectively.
Because what the 40, he died on the 40 something of March.
40 something.
The Ides of March.
Oh, I don't know.
I was like 48 BC, 40 something of March, whatever. But anyway, wow, this episode's going nuts.
Yeah, man. Also, so there was, I don't know if you saw this, but the Nobel Physics Prize that was won in 2019 had to do with the cosmic microwave background. Essentially,
and is that the image of the universe as we know it?
Yes.
Yeah. The whole image that we know it. Which, here, pull that up because that's important.
Yes. So the physics prize was gifted to 3 scientists. I don't know their names, and I'm terribly sorry. I want to give them credit. I don't know their names. I look into it. There's 3 of them, but they won the Nobel Physics Prize because they proved that fluctuations in the cosmic microwave background pretty much proved, or is strongly, I don't want to say believed, there's strong evidence to prove that the universe was born. That's just to boil it down. The fluctuations in the cosmic microwave background actively prove that the universe was born at a certain point. Now, that essentially, you would imagine it to be logical, because nothing can come from something, and you can't, like I said, the first law of thermodynamics, you can't make energy, you can't make matter, things like that.
Yeah.
So obviously something has to be born, but the fact that they were able to prove that the universe was born is insane. They were able to do it mathematically. I don't know how. This is above my head, because, like I said,
that's above your head.
That's above my head. I have no idea how. That's wild madman physics.
13.7 billion years ago.
14.7.
14. Sorry. 14.
That's a whole billion years, bud.
Dang, I got a billion years off.
Yeah, man.
I thought it was 13.7.
14.7.
Anyway, 14.7.
Yeah,
dang, and they proved it.
Yeah.
So they proved the Big Bang, or at least the start of.
So yeah.
So the Big Bang theory has a lot to it, right?
Yeah.
And so at least 14.7 billion years ago, the universe began.
Yes. Hang on, let me look at my notes, because I actually had a lot more than that.
Yeah, you had a lot more than that. Is there a part of that talking about
What?
Talking about the strands, the DNA of our divine creator in the multiverse theory.
Of
Do
Big
we
Bang?
know any more of that?
Of Big Bang? Or
Of Big Bang and the double helix and stuff like
so
that.
that's just my personal theory. That's not
Okay.
something that's been researched. That's something that I would personally like to research. That's something that I personally subscribe to because of the amount of intellectual thought I've put into it.
Yeah.
Because again, in order for a lot of these to align, you have to believe in certain things first. Like I believe in Big Bounce theory, which makes me realize and think DNA strands, double helix of divine creator. Because when you think about the scale of the universe and how big everything actually is,
Yeah.
it would make sense. Because everything that either is or always or will be is it just is. That's what reality is.
Yeah.
It's everything that always will be. It ever was. It's just how it boils down. So yeah, sure.
I want to ask you a question.
What's up, buddy?
What do you believe in a creator of some sort?
Absolutely. The reason being, there is too much mathematical accuracy for life to not have been actively created. When you look at things like the Fibonacci sequence, when you look at things like our place in the universe, when you look at things like the odds, we have the percentage chance for life to happen.
1 in 400 trillion.
1 in octillion.
What?
1
Whoa.
in octillion.
Life in general, because
Life
I
in
heard
general.
I know they proved the math of it to being a human being. It's 1 in 400 trillion, which I recently just sent this to a friend of mine
Mhm.
because they were feeling down about life. I'm like, look, man, you are 1 in 400 trillion
Yep.
chance of being born. You're telling me it's 1 in
Octillion.
octillion? Oh,
Because when you think about it, a lot of things have to be right. You have to have the right nitrogen percentage. You have to have the right oxygen percentage. You have to have the right pressure. We are always physically under pressure. We don't notice it because
it's normal.
it's our
for
normal
real.
life.
Yeah.
But we are constantly under 14.6 psi. Always. No matter
Right.
what. Unless you undergo some sort of external different type of pressure. Things like when you go up in an airplane and in a closed atmosphere, things like that.
Right.
Your pressure increases because as the air gets less dense, the pressure starts to increase on the cabin and things like that. Because
Right.
you're trying to neutralize the difference between. Because unless you're like a fighter pilot, you're not typically trained for that type of low density atmosphere breathing. But more often than not, we are always experiencing 14.6 psi at if you no matter what you're doing, unless you're sitting still, even sitting still, experiencing 14.6 like you and I right now. We don't
Right.
notice it
Right.
because that's just we have grown accustomed to it.
Yeah.
But
Yeah, if you go into outer space, your blood would boil, your eyes
Mhm.
would pop out your head, stuff like that. If you're just exposed to, outer space.
yeah,
And you would freeze instantly, burn instantly, all
which
at the
would
same time.
suck.
Yeah, so 14.7 psi, which is very specific.
Yes.
I mean, you just hit it right head on the nail, and that's why I believe in that there is a creator, even though I diverge from the religious aspect.
Yeah.
Because science can prove the creator. You can backward engineer all of it.
See, here's
There's
the thing.
math already there.
Yeah, exactly. It's just there for like the reason I like science and the reason I like physics specifically is because it's the science of observation. You, as an individual, can go outside and look at things and see things and determine what you're looking at. You can break it down. You can run experiments. You can do different things to figure out what this reality actually is. There is, I think it was Ricky Gervais. I think something. There was a video a long time ago that said, if let's say tomorrow, just randomly, nuclear detonation, nuclear war, all of the civilizations on the Earth destroyed, except for a couple thousand people. Eventually, at a certain point, life will start to come back. Life will start to regrow. Life will be into team again. And what's going to happen is that you're going to have people. Religions are going to be completely different stories. You're going to have there'll be no, let's say all Bibles get wiped off, all Quran, all Torah, all holy books get wiped away. The stories will come back completely different. They're going to be like, oh, an alien came from the sky and he landed on the earth and he said, here's some crap for it. But the difference is between that and science can be proven to a certain degree because there's no such thing as proof. There's just a lot of really strong theories that we can't deny.
Right.
Like when it gets to a certain point, it's like, oh, hey, there's no such thing as 100% like this is what it is. It's just something that's like, oh, hey, yeah, this is, we have recognized it to be the way that it is, and we haven't found anything to disprove it yet, so this is what we're going to believe. Like Einstein's theory of relativity. It's like, hey, this is what we have understood it to be. We're not going to challenge it right this minute. This is what we accept it to be. Now, somebody down the line might come along and disprove, theories of relativity. They might disprove other type of theories, but there's no really such thing as just like pure hard soil, undeniable evidence, because you can always argue that something can be disproven.
Right.
That was Ricky Gervais.
Yeah.
And you didn't say the part where if everything was destroyed,
Yeah.
we would have the science books. Those would be the ones that were always recreated.
Yeah, exactly. That's the idea, is that in a certain amount of time, science books will, because again, physics and science is observation. It's purely, you go and, as human beings, before we even have the opportunities to say, what are we, who are we explore. We were explorers. That's the thing. That's why we have explored the Earth. We have explored the oceans. We have explored space. So when it comes to things like that, also, I'm going to get into that soon. Let me get into frequency harmonics.
Yeah, so I think a good point. Dang it, I had it.
I'm sorry. Frequency harmonics, space, explorers.
Back. A little before that. I forgot it.
If it's important to come back to you.
Yeah, whatever. It's all good. Keep going.
Okay, so if I need to stop, just be like, hey, time, and I'll
No, just keep going.
So
I love this. This is golden. This is the golden sequence, the golden rule right here in this podcast right now. We are translating to you. This is something I always wanted to connect.
Yeah,
all
man.
the physics, the science,
Yeah.
and all that. Oh my! I've remembered. Okay, so also with that, if another civilization, like another alien species, wanted to figure out science and they developed as much as we, or even more than us, they would have a different language combined to it, but they would also figure out the same type of mathematical formulas because it's already freaking there.
Yep.
All energies near created, destroyed, everything. The Fibonacci sequence.
The laws of nature, the laws of physics are the same for every individual.
Yep.
Also, could you do me a favor, Dylan? Would you mind pulling up an image of something called the flower of life for me, please?
The flower of life.
The flower of life.
What is the flower of life?
So, diving back into math, because essentially, physics is what it is, and math is a language to understand the physics around us. That's why people struggle with math, because it's literally like learning a new language.
That makes sense.
So, what I want to show you is this right here. So, the flower of life comes from the seed of life. Okay. Now, ideally, and it's theorized, this again is not proven, but it's theorized that every single shape you can ever imagine comes from that shape right there. Every single piece of matter comes from that. The seed of life comes from the tree of life. Yeah, that's the flower of life, which essentially kind of makes life bloom. You have the seed of life, the tree of life, the flower of life. All of that dives back into esotericism, which again kind of ties back to divine creation.
Is that science?
It's math. It's actually math. That's math.
Jesus Christ.
And what's really cool is that specific thing. What is that? Does that remind you of anything specifically?
Oh man, it's not coming.
Think biology.
Cells.
Yeah, it reminds you of a cell, right?
Oh my god, that looks just like a cell.
So
cells together.
Oh,
cells all. Oh my god, what even? Math is so interesting.
Yeah.
I wish I dived more into math and understood it better, because my god.
So here's the deal. There is a very strong connection between biology, astronomy, and math. The mathematics that's strongly resembles. What else does it resemble? Does it resemble anything? Think astronomy. Just the shape, just the basic shape.
Stars,
the
galaxies,
yeah,
planets.
Yeah. So
Jesus Christ.
All of those kind of tie back into each other. And here's something else I'm going to blow your mind with. Okay, Dylan, would you do me one more favor, please? Will you pull up a picture of? I'm going to call it dark matter, dark energy web. Dark energy web. Yeah.
The web of dark energy.
Yes. So, as we exist in our everyday reality, out of the entirety of the universe, only 4% of it is matter.
Right.
4%. I'm gonna get into that very shortly. That's perfect. Thank you very much.
We're looking at a web.
Yes. Okay. So 4%.
That's matter. What we're
that
looking at.
is dark matter. So 4% is actual tangible matter, right? Then you have about, I want to say 14% is dark matter, and then about 86. No, that's bad math. Sorry. 14 is.
You could probably 18,
look it up. 82%.
Is that dark energy?
Dark energy, yeah.
Okay.
So here's the deal.
I heard that before.
Yeah. So my philosophy, what I think of it as, is that when you look out into space, it's very dark. Okay? Everything's black. Now, how dark energy and gravity kind of correspond with each other is gravity is space-time, pretty much. It's the warping of space-time. When you have an object in space-time, it bends space-time. That's just gravity. That's the way it works. But dark matter essentially is kind of the glue that keeps everything kind of held there. Like, let's say, for example, all the dark energy was pulled away. And think of it kind of like a white floor. Everything kind of like if you had a bag of marbles, all the marbles would kind of like fall on the floor. The dark energy and dark matter, or like dark energy pretty much, is what keeps everything kind of where it's supposed to be. Like in a 4-dimensional grid, kind of like intersects like that, where you have different objects that are suspended, stars, planets, galaxies, superclusters, everything. But here's the cool thing. Remember how we talked earlier about the double helix and how it's the divine power of divine creation?
Yeah.
What does that remind you of?
That reminds me of a web.
Okay.
Of like almost like a spider web.
Okay. Think a little bit more anatomical.
Anatomical. It looks like atoms. Your brain. Yeah, like
there you
neurons and connections like that. Yeah, of course that makes so much sense.
It looks like the neuroconnectors of your brain, right?
Yeah. Yeah, which we could throw an image up there of that even too, where it's.
So here's the cool thing is that these neuroconnectors are all connected to each other itself. So when you think about it, our individual universe, it depends on what level of theory you subscribe to. You can either go double helix, you can go super, super massive and go double helix as the DNA of the divine creator, or you can say dark energy is like the neuroconnectors of the brain. Because have you ever heard of the brain in the vat philosophy?
No.
Okay, so
I think I've heard of it. Explain it.
Essentially, it's pretty much like you and I. No matter how hard we try, we will never know if we're just brains in a vat. Because we very well might be brains in a vat that's being electrically stimulated to
keep going.
Have visual images to produce and make it seem so real that we will not know if we are brains in a vat being controlled by something. So the idea behind it is that this dark energy web might be the neuroconnectors, or it might feel like the neuroconnectors of a brain in a vat of a divine creator. If you want to subscribe to that, there's a bunch of different you can subscribe to.
Yeah.
Like there's double helix if you just want to go massive, massive big, because at that point you and I would be like quarks, or even maybe Plancks, like even smaller. So. Which we'll get into string theory in a bit. But, because string theory ties back into frequency. Because essentially, the components of matter, you have actual matter, and then as you get smaller, you have cells, then you have atoms, then you have quarks, then you have Plancks, then you have strings. Strings are essentially vibrating pieces of matter, which kind of create pixelated images of you and I. Like, you and I are just a compilation of millions of pixels of an image. That's what we are. So essentially, it depends on what you believe. It depends on what you want to believe. At a certain point, I think it's really up to the individual person to kind of think like, okay, I like this personally. Myself, I think it's awesome to go with the double helix theory. That's my personal opinion. I'm not telling you to subscribe to it. Don't subscribe.
Why?
Because when you think about divine creation and how mathematically accurate and how like massive the universe is, and you think, oh hey, I'm gonna throw it out there. If you think of God, right? You think of God, it's like, oh, it's this omnipotent, all knowing, all powerful, all whatever.
But we're made in the image of Him,
right? So when you think about it, why wouldn't the divine creator be so big? Why wouldn't they just be like, to us, we would imagine it to be extremely massive, but you never know. To them, they might be our size. You never like they might be exactly. Human size, but also ties into bubble universe theory and all that kind of stuff. There's a lot. I'm not kidding. There's a bunch of different types of physics that you can subscribe to. It really depends on your personal preference.
Right.
personally, to me, this is just kind of like the craziest off the wall stuff to me. So I like it because I'm a crazy off the wall kind of person.
Yeah, you're getting so much. You're blowing my mind so much. What
did I tell you at the beginning of this?
Whoa, what type of physicist do you want to be, bro? Because I think theoretical physics is where you're at right
theoretical,
now.
Astronomical. For a job, I think like I'd rather do my own research on my own time. But I think personally for me, with the job market the way it's going, space exploration is just too good of a market to not get into.
Yeah, exactly.
There's too much money to be made. There's too many discoveries to be made to not be in space exploration. Now, you can do, personally, I would like to be an astronomical optics physicist.
Okay.
Because Hubble, dope. Like, it's been up there since, 1990?
Yeah.
So we're overdue for a new optics telescope.
Yeah.
Dude, James
Webb.
Webb.
Oh, my God, yeah.
James
I wish
Webb.
they would just put that out there, man.
But the thing is that when you think about it, it's so expensive of a piece of technology, and the main thing that's holding them up is the unfoldable, solar panels. The mirror itself is fine. The mirror is fine. Which, cool fun fact. I don't know if you guys knew this or not. But
Maybe.
The James Webb Telescope is going to be so powerful that if it existed there, it could detect the presence of a bee on the surface of the moon.
On the surface of the moon?
On the surface of the moon.
So we can find the golf balls that Alan Shepard hit.
If they're still there.
They're still there, yeah.
Yeah. And what's cool is that it's going to be set at a Lagrange point. So, like, if we have the Earth here and then we have a Lagrange point here, it'll kind of just stay. I'm going to call this
pointing towards me.
LP. Yeah, I'm just going to label it as LP and then point to it. So if you have, like, this is the Earth, so I'm going to label it E. That's a really bad E. I'm sorry.
Can you see that okay?
Yeah. Sorry, that's just garbage.
Point it a different way. Point it down.
Is that better?
No, it's worse. Just point it towards Cody. It's just really small.
Okay.
All right, so we have a circle and E, which is us, and then you have your Lagrange point. Sorry, I realized I was not talking to the microphone.
You're good.
This is where James Webb's going to be. And then you have, like, the moon over here. It could detect the presence of a bee on the surface of the moon.
Jeez.
Which is so powerful.
That's insane.
And the thing about it, it's so expensive that when you put it there, there's no rescue missions. Like Hubble, you can go up there and fix it if you need to, because it's in lower Earth orbit. It's like 200 miles out. This is going to be closer a few thousand miles out of our atmosphere, so there's no going to fix it. You can't go there. So you do it right the first time. That way you don't have to go fix it. And in the event that anything goes wrong,
that's why it's pushed back so much.
Yes,
probably.
Because you don't want to mess it up.
Yeah.
And that thing's actually huge. I think it's massive.
It is massive.
It's
like
massive.
When they show it, it's so big and it's supposed to unfold and shit. And I'm just like, whoa.
And that's the part that's taking them so long, is the unfolding thing. Because again, the mirror's fine. The mirror works the way it's supposed to. But yeah.
Yeah.
Okay, man. All right, let's see here.
Holy cow! Where else do you want to go? I feel
let's get into actual like space flight, because I haven't gotten a little bit into that. So,
okay, space flight.
So as you're probably already aware, when they had shuttle testing, they would shake it a lot. Reason being pressure testing, harmonics.
Yeah.
They wanted to see how it would
react. Did they do
react.
harmonics?
That's the idea. That's why they shook it.
Wow.
That's why they shook it so much. Let's see what we got here. Yeah, that's James Webb. That thing is huge, dude. Look at that.
That's massive. That's bigger than Hubble for sure. Just
Hubble's only 2.4 meters long, or
what?
2.4 meters wide.
I didn't know that.
Yeah, it's only 2.4 meters wide.
That's not big at all.
It's not huge.
Wow.
But the thing about it is, the reason that it doesn't need to be so big is because the main reason we can't see on Earth is due to our atmosphere.
Right.
Like we have light scattering. That's why stars twinkle. Is because the light's being scattered through the atmosphere. But when you're outside of the Earth's atmosphere, you have a much clearer field of view. Look at that thing, dude. Look at that thing.
Yeah, that is insane.
What's that, 6.5 meters?
Yeah.
That's over 3 times.
That's massive.
Wow, that's 3 times as big
What
as
you know about the hexagon shape in Mother Nature?
So, dude, honeycombs.
That's insane. Yeah, honeycombs. That's freaking insane, right?
Flowers, seeds, pomegranate seeds.
The strongest shape in Mother Nature.
Yeah. But, like, they have multiple mirrors, so that way they can actually, like, get a higher res. Because if you have just one big mirror, it has the possibility to let some of the stuff slip through the cracks. But if you have multiple mirrors like that, it can actually get you what you need to get.
Yeah.
Yeah, man. Let's see.
God, how far are you through your notes?
Dude, I have gotten a lot through my notes, there's
I
a
feel,
few
I feel like you're
more-
definitely a theoretical physicist because like you have to. I thought about being a theoretical physicist when I was like 12 because
Mhm.
Albert Einstein was like my biggest idol.
Yeah.
But when I found out how much they had to write, I'm like, nah, forget that research paper, man. That research paper is insane.
Yeah,
And
man.
you're hitting a nail on the head with how much research you have.
Yeah. There's just
What's next?
let's see here. Let's see what we got. So
what you got? What you got?
the main thing when we're talking about like harmonics with space shuttles and things like that, the main thing we're talking about with space shuttles and just
You're just
other
gonna have to tell me,
space flight-
Dylan.
You okay?
We're at hour 30. Are you kidding me? Jesus. Okay.
Wild.
I need to take a piss break.
I mean, we
Do
can always
you?
make this a two-parter if you need to.
If needed. You know what? Is that cool with you? All right. I'm going to take a piss break. Let's take a piss break.
Jeez, man.
Holy fuck.
I told you I was gonna blow your mind.
I'm going to
I
edit
told
that out.
you.
I'm going to edit the shit out of this video.
Let's just end it. Why are we taking a piss break? We should just make it a two-parter.
Two-part. All right. Whatever. Do it.
Me do it.
Record me, and I'll say, all right, we're gonna make this a two-parter.
Record both of us.
Okay.
All right. We're just going to make this two-parted because this is going on quite a bit, and
I still
we're
have a
blowing minds.
lot more to talk about.
This man has a lot more to talk about,
A
and I love
lot.
it. Oh my god, this is great. So we're gonna take a quick break because we need to, and we're already at hour 30, and it's beautiful. And stay tuned.
Cool. Peace.
Holy fuck!